Have you ever gazed up at an airplane soaring through the sky and wondered, what incredible force propels this massive machine? The answer, my friends, lies in the heart of the aircraft, the jet engine. These technological marvels are a testament to human ingenuity, enabling us to travel thousands of miles in a matter of hours. But how do they work? Imagine a bicycle pump. You push down on the pump, and air comes out. A jet engine is a lot like a giant, continuous bicycle pump, but instead of just pushing air, it uses that air to create incredible power. In this exploration, we'll unravel the mysteries of jet engines and understand the principles that allow us to conquer the skies. Fasten your seatbelts and get ready for takeoff as we delve into the fascinating world of jet propulsion. Before we dive into the inner workings, let's familiarize ourselves with the basic components of a jet engine. Imagine a long cylinder with air flowing through it. This cylinder houses 4 key sections working together seamlessly: the compressor, the combustor, the turbine, and the exhaust nozzle. Think of the compressor as a set of spinning blades like a fan that sucks in air and squeezes it tight. This compressed air then enters the combustor, which acts like a furnace, mixing the air with fuel and igniting it. This combustion process creates a powerful blast of hot gases. These hot gases then rush through the turbine, another set of blades, causing it to spin like a windmill in a hurricane. Finally, the gases exit the engine through the exhaust nozzle at high speed, providing the thrust that propels the aircraft forward. Let's start our journey by understanding the crucial role of the compressor. The compressor is a vital component in jet engines, playing a key role in the overall functionality and efficiency of the engine. Picture this: you have a balloon, and you squeeze it. As you apply pressure, the air inside the balloon gets compressed. What happens? The air inside gets packed tighter, right? This simple analogy helps us understand the basic principle of air compression. That's precisely what the compressor does. It takes in air and compresses it, making it denser and increasing its pressure. It takes in vast amounts of air and compresses it, increasing its pressure significantly. This high-pressure air is essential for the next stages of the engine's operation. The compressor is made up of multiple stages, each consisting of a rotor with blades and a stator stationary blades. These stages work together to progressively compress the air. The rotor blades pull in the air and spin it around, increasing its speed. This rapid spinning motion is crucial for the initial compression. The stator blades then slow down the air, which increases its pressure even further. By slowing down the air, the stator blades help to convert the kinetic energy into pressure energy. This process of compression is crucial because compressed air burns much more efficiently when mixed with fuel. Efficient combustion is key to generating the thrust needed for flight. Think of it like trying to start a campfire. Using just a match to light a large log is difficult. But if you use small twigs and gradually increase the size of the fuel, you can build a roaring fire. Similarly, the compressor's job is to prepare the air for efficient combustion by squeezing it tight. By compressing the air, the compressor ensures that the fuel burns more completely and efficiently. This preparation is essential for the engine to produce the maximum amount of power. Without the compressor, the engine wouldn't be able to generate the necessary thrust to propel the aircraft. Section 4. The combustor, igniting the fire within. Now that we have a continuous flow of highly compressed air, it's time to add some heat. This is a crucial step in the engine's operation, as the heat will significantly increase the energy of the air, making it capable of doing work. The process of heating the air is what transforms it from a simple flow of gas into a powerful force that can drive the engine's turbines. This is where the combustor, the engine's furnace, comes into play. The combustor is designed to handle extremely high temperatures and pressures, making it one of the most critical components of the engine. It must be robust and efficient to ensure the engine operates smoothly and safely. The compressed air from the compressor is directed into combustion chambers within the combustor. These chambers are specifically designed to mix the air with fuel and ignite it, creating a controlled explosion that generates a tremendous amount of energy. Inside these chambers, fuel, usually kerosene-based jet fuel, is injected and mixed with the compressed air. The precise mixture of air and fuel is crucial for efficient combustion, ensuring that the engine produces maximum power while minimizing emissions. The mixture is then ignited by an electric spark, just like a spark plug in your car. This spark initiates the combustion process, causing the fuel-air mixture to burn rapidly and release a large amount of energy. Once ignited, the fuel-air mixture burns continuously, producing a powerful stream of hot, expanding gases. Imagine a firework rocket. The continuous burning ensures a steady flow of energy, which is essential for the engine's operation. When you light the fuse, it ignites the gunpowder inside, creating hot gas that expands and propels the rocket skyward. Similarly, in the combustor, the controlled combustion of the fuel-air mixture generates hot gases that expand and flow through the engine. The combustor works similarly, except the explosion is controlled and continuous, providing a constant stream of high-energy gases that drive the turbine. This continuous stream of energy is what powers the engine, allowing it to produce thrust and propel the aircraft forward. Section 5. The turbine. Harnessing the energy. Remember the hot expanding gases we generated in the combustor? These gases are not just any ordinary gases, they are packed with energy, ready to be harnessed. Now it's time to put them to work. The turbine is the next crucial component in our engine, and it's where the magic happens. These gases, filled with immense energy, rush through the turbine, which sits right behind the combustor. The turbine is strategically placed to capture the maximum energy from these gases. The turbine is connected to the compressor by a central shaft, forming the engine's core. This connection is vital as it ensures the continuous cycle of energy conversion. As the high-energy gases blast through the turbine blades, they cause them to spin rapidly, much like a windmill in a strong wind. The faster the blades spin, the more energy is harnessed. This spinning motion is then transferred back to the compressor via the central shaft, powering it to draw in and compress more air. This cycle is what keeps the engine running efficiently. Think of it like a water wheel in a flowing river. The continuous flow of water keeps the wheel turning, generating power. The water's movement turns the wheel, which can then be used to power a mill or generate electricity. This analogy helps us understand how the turbine works in a similar fashion. Similarly, the turbine extracts energy from the hot, expanding gases, essentially harnessing the power of controlled explosions to keep the engine running. This process is a marvel of engineering, converting raw energy into mechanical power.